Good morning. Welcome to Chemistry 109. I hope everybody's in the right class, and if you're not, I am Mrs. Brooks, and you are in Chemistry 109. First thing we're going to do today is talk about the syllabus. And this is kind of an interesting lecture today because if you are watching this on the video for the first time, chances are the reason you're doing that is because we have a total solar eclipse coming on Monday, August 21st, 2017, which is your first day of class. But you are missing your first day of class for that great event. So we are going to talk via video today. So kind of an interesting thing. All of the lectures this semester in Chemistry 109 will be on film, so you will have the opportunity to view these at your pleasure, and I hope you do. So, just a heads up for those of you in this class that are watching, there will be a special test question based on some information on this video, and since you don't know what it is, you might want to continue watching, okay? All right, so this is Chemistry 109. I'm going to go over the syllabus with you rather quickly. And then we will have class tonight. So we will have class, and sometimes I will be honest with you, I'll probably say tonight, sometimes I'm going to say this morning. This class is taught at 8 o'clock in the morning. It's also taught at 4:50 in the afternoon, so I may be messed up on my time. All right, I am Mrs. Brooks. Now I'm going to flip over already to the last page on this syllabus. I hope you printed one out. And this is the last page of the syllabus, and it shows you my office hours. It also has some other useful information on it, and I did that on purpose because some of you don't know where or how to get a hold of me, and you also never remember these conversion factors, so I put them all on the same page, and you can stick those maybe in your bathroom or somewhere where you wait. Have those handy so that you can study those and look at that. So that's where I am. Phone number goes straight to voicemail. If you leave me a voicemail message, it will come to my email, so I will get that. All right, who is supposed to be in this class? Guys, at this point, you've received probably 3, I know, emails from me. Honestly, you're probably going to have received 4 or 5 by the time you get this lecture. So you should know whether or not you're in the right class. If you have questions about it, Wednesday, we'll talk about it more. But you should be in this class, especially if you're a nursing major. And other than that, talk to me or you've received the email. So I'm not going to go through this. I want to talk about math. If you have not had math in a long time, or if you have only qualified to take Math 096, don't take this class. You need to have a good math background in order to succeed in this class. Again, hopefully you've read the emails and you know what's going on. Talk to me if you don't. Great news about the text. You don't have to buy it. The text is free. We are this semester doing a free textbook. Now, if you're in one of the other Chemistry 109 classes from your past, or you've had one of those in the past, you did use a textbook, you bought the Connect program. We're not doing that this semester. This semester, my class only, both of my classes have a free textbook, and this is accessible via this web address. You can also download the PDF. I would suggest that you use this link first. If you want to download it, you may, but this one is a much easier one to navigate. So the only thing you're going to have to buy will be the Sapling Homework Program, and that is something that will be available to you, and it will be billed. It's available to you now. It will be billed to you around probably about September 1st. And so you'll want to look there and see if you get a bill from the university for about $38 and then pay that. But that's it. This semester, that's all you have to pay for Chemistry 109. So pretty cheap 4-hour class. What else do you need? You need a calculator. I'm going to talk about calculators real quickly. I've, again, sent an email about this. These are the 2 calculators that you may use. You may not use a graphing calculator. I'm trying to block the glare there. This is the TI-30X2S. This is the TI-30XA. This is my favorite calculator of all time. It's extremely simple. If you have been used to using a graphing calculator, I would get this calculator. But either one is fine. You may not use a graphing calculator, and you may not use a cell phone. Which brings me to mind, take your cell phones and turn them off if you haven't already. Make sure your cell phones are off. I want to tell you about last semester. Had a student last semester, sat back in the back. Probably at least once every 2 weeks, she was on her phone. Now, guys, you think, well, why do you care? I'm paying for this class. Who cares if I'm on my phone? I'm going to tell you right now, you're on your phone. I'm going to tell you to get off of it. This particular student and I had quite a few run-ins. She got very angry with me after several times because I should have done what I finally did do, and that's walk back there and say, give me your phone. Now, it's right here on my syllabus. It has been forever, and I will probably be harder about this semester. After a first electronic device offense, I will request you leave class or give me the device. If you refuse, or if you have another offense, do you see this? You will have overall course grade, maybe lowered a letter grade. I'm getting mad about this, okay? So put them up. Put your phones up. Now then, we do have an electronic textbook, and I realize you're saying, oh, well, can I bring my laptop in and look at the book? And I understand that you may want to do that, but I'm also going to tell you right now, you don't need to. My lectures are going to be good enough. You're going to find that's more distracting. So if you were a person who feels like you need that out, let me know, and I'll work with you on an individual basis. Overall, you're not going to want that out, though. Okay? Grading. We are going to have a few assignments that are graded, and each of these is going to be quite long. So it's a few assignments, 5 to be exact, 5 homework assignments. They are 23 points each, and they will be graded, and they are due the evening, the day before the exam. And if you want to write on your syllabus, this is due the evening at 8 p.m., and that is on the schedule, and I'll show you that in a minute. You cannot turn this in late. It is due the evening before the exam, and I changed that a little bit, and the reason I did that was so that you would get it done before 9 o'clock the morning of the exam. So you can get to bed early and maybe study instead of just working on homework at 12 o'clock that night. There are also going to be 4 100-point exams. They are all multiple choice. Exam 5 is also 100 points. It is held the day of the final exam, and it also has 25 points that are comprehensive. The only way you can make up that exam is if you let me know ahead of time and you have an acceptable excuse. Again, let me point this out. You have to let me know ahead of the exam. You cannot show up 3 o'clock the afternoon you were supposed to take an 8 o'clock exam and say, oh, Ms. Brooks, I forgot we had an exam. That's not prior if your class is at 8 o'clock. Now, are we able to interact within the classes? In other words, can you come to a 4:50 class when you have an 8 o'clock class? Or can you come to the 8 o'clock class when you're normally at the 4:50 class? Talk to me and I will work with you on that. It's all going to depend upon room size. So let me know and I'll try to work with you. All right, the next couple of comments here are basically some things that the university requires us to put up, and that is the discrimination and harassment policy as well as students with disabilities. If you have a disability, you need to let me see your letter of accommodation if you want me to accommodate you. And then there is this long blurb on cheating. So let's talk a little bit about me. I started teaching at Western in 1998. So I've been here almost for 20 years, and I taught high school for 4.5 years before that. First time I ever caught a student cheating in high school, I was scared to death. The student had a big coat on, and they had put some stuff underneath and inside the jacket, some little cheat sheets in there. And I was shaking. I felt like I had had a wreck inside. I mean, I was weak, and I knew I had to confront them. Now, when I catch somebody cheating, it's like a rush. I love it. Okay? So let me catch you, because it'll make my day. And I will catch you. So don't cheat. All right? I do not want you to be 35 years old and lying in bed one night saying that was just so stupid. I should never have cheated. Okay? So please don't cheat. If you do, I will catch you and I will enjoy it. So don't do it. Okay? Now, if you don't know what cheating is, this is cheating. Let me give you a little more examples of what is cheating. Obviously, cheat sheets are cheating. Obviously, looking at somebody else's paper is cheating. But here's the one that everybody thinks isn't cheating. You're sitting down and doing your sapling homework with your friends. And Johnny does this problem and Jimmy does this problem, and you sit there and say, what did you get for those? And you plug in the answers. That's cheating. Now, is that going to do you any good on your test? No, it's not. Am I going to go home with you? No, I'm not. But it's not going to do you any good. Most of you in this class want to become a nurse. I don't want you to be a cheating nurse. Okay? So please, just do your own work. You'll feel better for it when you're older. So please, just be honest. It's always the best policy. All right, this semester, change in my past. Now, you've not had me before probably, but the change is attendance. I am going to give you a bad grade if you don't come to class. So let's talk why. Because you're watching a video lecture right now. Every class period, you are going to have a video to watch if you choose to. So you're thinking, and I would think the same thing, hey, I don't have to show up for class. I can just watch the video. Yay! I can just be free. I don't have to come to that 8 o'clock class every morning. I'll just watch the video. Not, because here's the rules. If you have 4 absences, you get the grade you get. You can have up to 4 absences, and you get the grade you get. You earn, okay? But if you have 5 absences, and I don't care what your excuse is, I don't care if Grandmama Judy died, and that's my mom's name, by the way. I would care if she died. But if she dies, and you had already had 4 absences because you were just lazy, and then Grandma Judy died, sorry. That means you have 5 absences now. That means you earned an A, you get a B because you were absent. 6 absences or 5, you drop your overall letter grade down 1. 7 to 8 absences, you will drop your letter grade down 2 letter grades. 8 or 9, it'll be lower 3 letter grades. And if you have 10 or more, I'm just going to fail you because chances are you didn't get the material anyway. So make sure you're clear on that, and we'll have more time for questions and answers on that next class period. But make sure you understand this. Monday the 21st is the Great Solar Eclipse. The university has canceled classes. That's why you're watching this video. Otherwise, we have class unless it's canceled per the university policy. So make sure that you're paying attention. This class is worth 640 total points. Now, I'm not doing the math for you, but you can do it yourself. Take 0.895 times 640, and that will tell you how many points you need to earn to make an A. Now, I see something here that's a little goofy. This should say an up arrow. It's got to looks like a figure 8, probably a sigma sign there. And this should be the down arrow. So it's 89.5 or above, you get an A. 59.4 or below, you get an F. And we'll talk more about that. You're responsible for your grades. You can find them on Blackboard. Now, I'm going to stop right here for a minute, and I want us to look at Blackboard site. So this is our Blackboard site that you're seeing on the screen now. And everything you've received from me is already showing up here as an announcement. No matter which class you're in, the 109 8 o'clock or the 109 at 4:50, this is showing up already. Everything is here. I want to point out just a couple of things for you to be looking at. So we're just going to, both of these are the same course, so I'm just going to go ahead and pull in. The first day you actually see me, you are going to be completing a form that gives permission for you to be in this class. Rather, you're giving permission for them to video your voice if it is on the recording. And that's what this is talking about. If you've got a problem with that, let me know. All of these you've received, I'm not going to go through these. What I want to point out is this classroom lecture material You need to go ahead and print out at least 2 or 3 days worth of notes. You can see some of these. I have answers already posted. Again, that's no excuse for not coming to class. I did that to help you. Videos and worksheets. This is where you will find the video lectures. Chem 109 class lecture videos. That's where you're watching this video from today. Extra practice videos are all below. And the worksheets that go with these are all below as well. These are just lots of practice that I've done for you. Sapling homework is very important, and this page shows you exactly where to go and how to sign up for your homework program. I'm going to go ahead and just show you a little bit of what that looks like. Notice I've clicked on Sapling Learning, and I'm going to go over here to U.S. Higher Ed. And then it will go through create an account. And as you go through here, this is where it talks about select an institution. That's where you're going to select Western Kentucky University. Once you hit create my account, it's going to take you to the Western page that has our homework assignments on it. And then at that point, you are going to look for the Chem 109 Fall 17 Brooks. If you're in my 8 o'clock class, your key code is 800. It'll ask you to put that in. If you're in my 450 class, your key code is 450. If you have any trouble, this is the information you need to assess that. Call Sapling. Please don't send me an email. If you have trouble with Sapling, call them. It's a very, very easy to use program. Occasionally throughout the semester, I'll have you look under the extra practice worksheets page. In fact, Wednesday, August 30th, you have an extra credit dimensional analysis worksheet that's due, and this is where you're going to find that worksheet. So this is it right here. That's the worksheet. You'll want to go ahead and get that printed out and work on that probably over the weekend, the first weekend of classes. Other than that, I'll refer to this occasionally throughout the semester, but we're going to go ahead and get started with our other things today. Going to go back to the syllabus and look at the syllabus for a minute. This class has the opportunity to earn extra credit points. I feel so strongly about your success in chemistry that I am giving you the opportunity to be paid to earn extra credit points by getting the help you need. And so what we're doing here is I'm paying you a half of a point every every session that you go to for tutoring. So if you go to tutoring, you can get a half a point. And we have a pass leader, and our pass leader is Dakota. Dakota will be here on Wednesday. You'll get to meet him. In both classes, you'll get to meet Dakota. And he will be here. He has had the class before. He made an A in the class. Excellent student. He is going to hold sessions with you. You do not have to attend the sessions. They are for your benefit only. They are not required. And he's going to hold these sessions on Tuesday and Thursday. The tentative times are listed here. I'll change that if it needs to be. You may also go to South Campus for tutoring. You may also go to the Chemistry Tutoring Center. I will put this information in more detail on Blackboard as the exact hours become available. The key is right now what I want you to realize is for one low price, you not only get this class, but you also get Dakota, who is free of charge for you to go to his past sessions. You get videos to watch after you've been in class to also confirm you understand the information. You get help from the chemistry department. You get help from South Campus. You get me with 20-some-odd years of experience. So you get your money's worth in this class. If you fail the class, it's honestly your choice to fail because we give you every opportunity to pass this class. So we hope you'll take advantage of the opportunities we're giving you. Now then, last thing I want to just mention before we actually get started on lecture today, this is our schedule. And I am pretty detailed. I've been doing this long enough that I can pretty much tell you this is about the way we're going to do things. And I've gotten real fancy today, and I've given you lots of color. I've tried to be very specific where assignments are due, okay? There are only 2 extra credit opportunities, and that is the extra credit that I told you about already, the dimensional analysis worksheet, and then the bonus quiz over ions. That's, again, more information on Blackboard. Every test day is written down. Your final exam is also written down. Every homework assignment is written down. There's no excuse for you to miss it. It's all here. First thing. So we're going to get started today. And yes, you can see today, what did it say we're supposed to be doing today? Syllabus, that's what we're doing. Elements, matter, and scientific, or we probably won't get to scientific notation, but we're going to do significant figures. So last thing before we get going, how are you going to pass this class? Well, honestly, if you don't pass, it's probably because you either didn't try or you didn't have the background. Read this when you have time. It's good to use this for any class, and honestly, right now, you're not really paying attention because you're just overwhelmed or you're just not caring. Regardless, I'll talk more about this, but when you get a chance, read this. Students who do this tell me it works. So I'll talk more about how to pass it probably after you fail that first test. We'll talk more about it. All right, first thing, grab that periodic table that I gave you. Now, if you're watching this on video, I didn't give it to you, so hopefully you printed out the periodic table. Well, where is that, you're saying? Let's go back to Blackboard for a minute and go down here to Classroom Lecture Material. Right there, periodic tables. There is one periodic table that says Periodic Table Need to Know, and this is all marked for you. All of these are marked. Now, what does this mean? Hit that little sticky note and you'll see. Well, maybe you'll see. Maybe you won't see. Well, it's not working, but regardless, what it says is you need to know these 56 that are marked. Marked, what does marked mean? It's got a mark on it. That's what that means, okay? X's, these are lines. All right, everybody see the marks here? Notice these aren't marked. That means you don't need to know them. These are marked. There's 56. So I'm not going to take the time to go through today and say these all to you. What I am going to tell you is this. What do you need to know? What do you need to know? When I say you need to know these, what do I mean you need to know these? Well, it's not as hard as it may look. You don't need to know numbers. You don't need to know anything other than the symbol and the element. For instance, if I say to you calcium, you are going to say Ca. That's calcium. If I say to you iron, you're going to say Fe. If I say Na, you're going to say, anybody know? Sodium. Very good. Okay, so that's all I want you to know right now. For the first test, that's all I want you to know are the symbol and the name. That's it. 56 of these, and you're saying to yourself, well, which ones are going to be on the test? I'm not telling you. It could be any of the 56. One more thing I want to point out to you before we leave that, because this is where, yes, I am picky, and you're going to say, man, she's picky. Yeah, she is. She's really picky. So here, let me show you how picky I am. You should have to live with me. Then you'd really think this, okay? Let me show you. Whoops. All right. Now, earlier you told me that's sodium, right? Okay. So this is what I wish I could do, and I'm not going to do this because, as you recall, these are multiple choice tests. But if it weren't a multiple choice test, this is what I would do. I would write sodium and you would write Na. So let's say that you wrote that. And good, I'm seeing some head shakes. No. But you say, well, that's how I write my lowercase a. Well, you're wrong. That's not right. This is a capital N and this is a lowercase a. Man, you're picky. Yeah, she's picky. Okay, well, what about this one? No, that's not right either. Well, that's how I write. And your name is Sally, and you write everything big. It's still wrong. Okay? It's capital N, lowercase a. Go back to kindergarten and learn how to print. Capital letters first, lowercase letters second, okay? Why do I care? You're saying, who cares? Why does it matter? Guys, what kind of teacher am I if I teach you wrong? I'm not worth 10 cents. It does not do you any favors if I teach you wrong or if I let you get by with doing something wrong. You didn't get your money's worth if I let you do something wrong. So I'll try not to. So that's where I am going to be picky. Again, you will see this on your first test. Now you're saying, well, how can you do this in multiple choice test? Here's what I can do. You've got 56 you're supposed to know. So I might say to you, which of the following elements does not have a symbol that starts with N? And then give you a bunch of them. And so you have to know the symbols for all those 5 choices in order to know if they start with N or not. Different things like that I can do. So, any questions on that? All right, one thing I will tell you I know I do, I say so a lot. Just so you know. I will probably say so a lot. All right, let's get started. Now, at this point, you are probably, some of you, going to be a little bored because this is old material that you're like, oh my gosh, we learned this in kindergarten. And yes, some of you did. I actually used to go to, and I do actually, first grade, I went to my nephew's first grade school and we did matter, states of matter. So you learned this a long time ago, so you're saying, why is she teaching it now? Because unfortunately you forgot. Okay? So that's why I teach it now. So let's real quickly, we're going to go through this. What are the 3 states of matter? They're also called types of matter, states of matter, phases of matter. Come on. Solid, liquid. Everybody always wants to say plasma. We're dealing with the 3 states of matter, solid, liquid, and gas, okay? So solid, liquid, and gas are the 3 states of matter we're talking about. Now, if it's not matter, it's what? Energy, very good. If it's not matter, it's energy, okay? So there's it. It's either matter or it's energy. So we're talking about matter, and we're talking about solid, liquid, and gas. So let's look at solid. A solid has a what? Definite shape and definite volume. Good. A liquid has, what's it got a definite of? Definite volume. But what about the shape? Shape of what? Container. So, show you something here. This is water. This is not moonshine. This is water. So, if I wanted to pour this on the floor, which I'm not going to, I have broken many of these jars. I've been drinking out of a jar for, 20 years probably. And I've broken many of them. But I'll try not to today. But if I were to pour this on, this is about a quart. This is a quart jar, by the way. This is almost a quart of water in here. If I were to pour this on the floor, does it seem like it's more than this? It does, doesn't it? Why? Because it takes on the shape of the floor. So it's like you can see it and say, oh, there's not that much in there. But if I poured it out, it seems like a whole lot more. So I'll try not to. So liquids take on the shape of their container. What about a gas? So meaning it has no what? It has no definite shape or what? Or volume. That's why if I let a really good one up here, you guys in the back are going to smell it. Why? Because I'm letting it out here. And what's it doing? Taking on the shape of the container. So, aren't you glad I'm not? Yeah. So you're watching on video, so you didn't get the thrill of that one. No. So, all right. But it would. What about the volume? It takes on the volume of the container. Now, what if I let a really, really, really good one and I come up here and open the door? Could somebody walking by potentially smell it? Yeah, because it's going to go on out the door if I open the door. And it could sneak through the bottom of the door. But, so the 3 different types of matter, states of matter, solid, liquid, and gas. Now, all of you knew those. That's great. You've always had those forever. But I want to teach you one thing you probably didn't know, and that's about a solid. There's actually 2 different types of solids that we seldom hear about. And they are amorphous and crystalline. Amorphous and crystalline solids. And the word amorphous basically means a solid without shape or form. A solid without shape, or form. And this solid is the answer to what you all wondered about Jell-O. Jell-O. They used to have a great commercial. Watch it, wiggle, see it, jiggle, Jell-O, brand gelatin. And you think about Jell-O. Now, again, you probably may not have had a square of gelatin in a long time, but imagine that square of gelatin on your lunch plate. And it's shaken, but it's kind of wet and it's kind of solid. What is it? It's an amorphous solid. So that's the answer. It's an amorphous solid. But here's one. Now, that one makes sense. So you're like, okay, some examples. Jell-O's an example. Great. Well, plastics, gels, those are all amorphous solids, and they all make sense. But here's one that doesn't. Glass. Glass is an amorphous solid. And you say, why? How? I thought it was crystalline. Well, before we even answer that, let's talk about crystalline for a minute. Crystalline has a regular 3D pattern. Crystalline has a regular 3D pattern, and examples of crystalline are going to be obviously crystals, such as quartz. So quartz would be an example. Metals, salt, sugar. If you've ever looked through a magnifying glass at any of the salts or sugars, you've seen this before, that regular repeating three-dimensional pattern. So then we're thinking, but okay, glass, you're telling me glass is an amorphous solid. How can glass be an amorphous solid when I thought that was like crystal? You know, I went and got married and registered for my crystal. But it's glass. How? Well, the best answer is to go to an old building. What do you see in old buildings that tell you glass is not crystalline, but it's amorphous? Thicker at the bottom. Now, have you literally seen it be thicker at the bottom? What do you see that tells you it's different? It's wavy. Go down Chestnut Street, go down State Street, drive down through an old part of town, and you can be the expert on windows. They've replaced the glass in that window. Well, they haven't replaced the glass in that window. Well, now, how do you know? Because if you see waves or distortion, that is an old piece of glass. If you see something that's perfectly transparent, looks like this jar that is totally, you can just see right through it, no deformities, that's a new piece of glass. And so that is proof, and yes, it is thicker at the bottom. It's hard to see that, though. Old glass is thicker at the bottom than it is at the top. Very old glass. And what's amazing about glass is glass has been around for hundreds of years. Like 350 years we've had glass. That's just insane to me to think. In the 1700s we had glass. But we did. We had glass for a long time. So, pretty interesting. But that's probably new. The rest of this old hat, you're like, okay, but that's new. So I want you to just know that. I don't know that there's going to be a test question on it. I just gave you that, okay? Now, there's something else I'm going to tell you right now in chemistry class that you're going to find out about chemistry class. You are going to learn more than just chemistry in chemistry class. I often will give you little side bits. Lots of little times you get freebies. So here's a freebie for you, okay? This is like your side lecture for today. Are you matter? You're shaking your head, yes. Okay, so you're matter, meaning you are just a hunk of matter, right? You take up mass or you have shape and volume. Oh, wait a minute. We can't say if you're matter or not. You don't even know what matter is, do you? Oops, what do we do here? Have we done what we aren't supposed to do? We have. We've talked about matter, but we never defined matter. I made an assumption you knew it. Wait a minute, let's go backwards. What is matter? Anything that has mass, and what? Takes up space. So right now, did we talk about solids having mass and taking up space? We've talked about liquids having mass and taking up space. We've talked about gases having mass and taking up space. So they're all matter. Now then I said, are you matter? But we hadn't defined it. So are you matter? So you're a big hunk of matter. Do you have mass? Do you take up space? Okay, so you are matter. Now here's your psychology lecture for today. Do you matter? Yes, you do matter. We have some depressed people in the room. So you do matter. Now, why do I say this to you? Because, guys, there is going to come a day, and it might be after that first test, that you're going to feel like digging a hole, crawling in, and eating worms and never coming out. And if it hasn't happened to you, it's coming. Believe me, you're going to have a day one day where you think, I don't matter and nobody cares. Well, let me just tell you, you do matter, you are matter, and I do care. I want you to succeed in this class. So, you are matter and you do matter. Don't forget that, ever. Don't ever forget that. You all matter. No matter how bad it is, you matter. Okay? So, we've talked about the big categories matter. We know what matter is. We know we're matter. We know we do matter. We know the solids, liquids, and gases. By the way, which state are you? All of them. You're all of them. Absolutely. You're all three. And lots of things in between. No, you are all three. Definitely. All right, so now let's look at the properties of matter. We're going to look at both the properties and the changes that matter undergoes. The properties and changes. And we're only going to look at two words here. Physical and chemical. Physical properties or physical changes and chemical changes. So let's talk first about physical changes or physical properties. When I use the word physical, I'm talking either changes or properties, both of them. I'm talking both. So what are those? Those properties that do not alter the chemical composition. Physical properties are those properties that do not alter the chemical composition. So what are some examples of physical properties? Can you think of any? Color. So any appearance. Somebody I heard say something, temperature. Let's talk about, instead of temperature, let's go a little further and say melting, freezing, boiling point. Now, what does that mean? That means if I say to you that water freezes at 0 degrees Celsius or 32 degrees Fahrenheit, is that a chemical or physical change? Or a property, rather. That's a physical property. That is a physical property of water. Now, if I tell you that I have steam, that is a change that has occurred, but it's a physical change. So changing the state, changing the solid, liquid, or gas state is simply a physical change. That's only a physical change. Now, when I walked into this room today, or when you turned on your computer and saw me on the video, some of you will be able to tell me when you see me again that I've worn this outfit before. Because some of you are like totally physical appearance oriented. You can tell me anything about clothing, what people look like, if they have glasses, if they have beards, etc. Me, somebody could rape me, rob me, and I couldn't tell you what they look like. But I could tell you what they smell like. I notice smells. Now, do I change you by smelling you? No. What is smell? Smell is a physical property. Now, we don't go around tasting people, but taste is a physical property as well. The way things taste, that's a physical property. Now, another one that we think of that we don't realize, some of you will know this one, but some of you probably never even thought of it, density. Density is a physical property. What is density? Density is mass divided by volume, and we're going to get to that next day. But density is mass divided by volume. Now, let's talk about that. If I wanted the density of this, let's just go with this little, actually, let's go with a set of keys, probably. That'd be maybe easier, or a key. Let's just say I took this key and I wanted to know the density of this key. I would get the mass of this key, and then I would get the volume of the key. And I'm not going to go into the details of how to get the volume right now. But does it change this key to get the mass of it? Is it still the metal and plastic key? Absolutely. To get the volume real quickly, you use water displacement, meaning you'll put it in water and the water rises. But in other words, I'm just putting it in water. Does that change the key? No, this is not going to react with the water. So does it change this key chemically to get the density of it? No. So density is a physical property. We can use physical properties to actually identify substances. Substances can be identified with physical properties. Chemical properties are different. Chemical properties are those that do alter the chemical composition. They are the properties that do alter the chemical composition. You will notice and observe chemical properties when you have chemical reactions. Chemical reactions, anytime new substances are formed, anytime new substances are formed, you are observing chemical changes or you are experiencing chemical properties. So, give you an example of that. Sodium, when placed in water, has a violent reaction, and sodium hydroxide and hydrogen gas are formed. That's a chemical property of sodium and a chemical property of water. But if I said to you, if I put this in my freezer, it's going to change into ice, that's what kind of property? Physical property. Burning, anytime anything burns, that's chemical. So anytime burning is occurring. And what are some words for burning? You could say oxidation, could possibly. Combustion, that's a fancy word. But if I say the combustion of carbon or sugar, let's say the combustion of sugar, or really what you're probably thinking, combustion of gasoline. Combustion of gasoline or combustion of alcohol. Is that changing the alcohol or changing the gasoline chemically? Yes, yes, yes. Most of your chemical changes are going to also have physical changes occurring as well. They will have both, okay? On your test and on your homework, you are going to see examples of physical properties and chemical properties. On your first homework assignment, sapling homework, you need to start that as soon as you finish watching this lecture. You need to start your sapling homework, and you are going to find questions that are going to say, which of the following represents a physical property, or which of the following represents a chemical property. So pay attention when you're doing that homework, and go ahead and start on that. So we've looked now at matter, we've looked at the states of matter, we've looked at the properties and changes of matter, physical and chemical. We're going to go again and look some more at matter. Now, give you an overview of what's going on. You know, I've listened to a lecture, or not a lecture, just a speaker on how people learn. And some of you like details. Some of you, though, and I'm a detail person. Some of you, on the other hand, though, are thinking the whole time, who cares? Where is she going with this? What's the big picture back here? So occasionally I'm going to try to remember that, and I'm going to stop and say, okay, what are we doing? What's the big picture? So here's the big picture. Chemistry is the study of matter and the changes it undergoes. Chemistry is the study of everything. So we're going to learn about matter. And matter is like the big heading here of everything we're doing. And then there's all these little sub-things. Today, where we are right now in this little short scenario is simply looking at a couple of ways to classify matter. Guys, if I ask you, how can I classify you? Well, Travis, I can say he is a student, he is an employee, he's a videographer, he wears purple shirts, he's been in the band before. How do I know all this about Travis? Because he's got a shirt that says a band shirt. He may have just gotten that shirt somewhere else, but that's what I can think, okay? He is a son. He's somebody's son. He could be married. I don't know. He could be single. He could be a father. He can't be a father. Who knows? We don't know. The point is are there tons of ways to classify every one of us? I can be classified. I can be classified mother. I can be classified wife. I can be classified as a teacher. I can be classified as a Christian. I can be classified as a farmer. That's a funny one we'll talk about later. So I can be classified as any of those things. So if we are human and we are matter, think about how big matter is. Could matter have 1 million plus classifications? I mean, I just jerked off 5 in my hand immediately for me, and I think I even had more for Travis. And I could give you tons more for me of classifications. So if we have that many classifications, then don't you think matter has a lot of ways to be classified? So how many are we getting to? Like this many. So let's keep going. Here's another way to classify matter. Matter can be broken down into substance or mixture. Okay, what does it mean if I say we have a substance? A substance, the best way to talk about a substance is to say it cannot be physically separated. A substance cannot be physically separated. A mixture, on the other hand, can be physically separated. Now, another little side note, I have to teach you something else here. This is your spelling lesson for today. There is a rat in separate. If you did not know that, there is a rat in separate. Many of you wrote that down, SEPERATED. There is a rat in separate. So that one's free of charge for you. All right. So, pure substances cannot be physically separated. Mixtures can be physically separated. All right, we're going to get to that physical separation in just a minute. I want to stick with substances first, though. We're going to talk about substances, then we're going to come back to mixtures. There are only 2 things that can be substances, and those are elements or compounds. That's it. Only elements or compounds, period. Again, on your homework, you're going to have questions that are going to say, classify the following. Gold. What would gold be classified as? It's a metal. Now, you all went way farther than I've even taught you, so that's hallelujah. You knew a little chemistry. I hadn't even mentioned metal in this class. Solid. I could say gold is a solid. Give me words. Element. Element. Now, could I also say it's a substance? Follow? So it's an element, but it's also a substance. Is it matter? Does that make sense? And yes, it's a solid. It's shiny in its appearance. Is that a physical property of gold? Do you see? All those different things we've just described about gold by just knowing what gold looks like, basically, and knowing a little bit of chemistry. Sodium chloride. Compound? Is it also a substance? Yes. It's a solid at room temperature? Yes. Okay. All those things are words that describe what we're talking about. But now then, what if I said salt water? What are you going to tell me about salt water? It's a mixture. What about that water I'm drinking? Is it a substance or is it a mixture? It's a mixture. What does the water that I'm drinking have in it? Where'd I get it? You don't know, but where do you think I probably got it? Out of the tap. Now that's the fancy word. Tap water means any water that is not pure compound H2O. And you say, you mean we're not drinking H2O? Yes, you're drinking H2O. But this H2O has things added to it. For instance, one of the things that's added to this water is fluorine, chlorine. There's iron in the water. There's calcium in the water. There's all kinds of things in the water. And you say, well, how do you know? Well, let me tell you how to know. You've done this before, some of you. Boil a pan dry on your stove and go back and look at it, and you're going to see white stuff in the bottom of it. That's the stuff that was dissolved in the water. Well, gross. I don't want to drink that. It's good for you. Some of it's good for you. Dental hygiene majors. Some of you are dental hygiene majors in here. What do your teeth need to stay healthy? Fluorine. That's why they put the sodium fluoride in our water to make us healthier. In Washington State, my niece has lived in Washington State. She has 2 small children. Guess what they don't put in the water? They don't put fluoride in the water. So what do they have to do? Everybody's got to give their kid fluoride drops. Now, which is easier, fluoride in the water or drops? Fluoride in the water. Okay? And so that's good that we have it. It keeps our teeth healthy. So we are drinking a mixture. How are you going to know on a test or homework that I mean tap water? Because it's going to say that. It will say tap water or faucet water, if that's what I'm talking about. If it's pure water, it will say pure water, and that means H2O. So if I said to you, what is pure water, what are you going to say? What word? Compound. Pure water is a compound. Pure water is a compound. Okay, so let's look then, one more thing. Elements cannot be broken down chemically either. Elements cannot be broken down chemically. Cannot be broken down chemically. What can they be done? How can they be broken down? This, everybody's going to say this or think this. We can separate fission, fusion, not fusion, but nuclear is the word I'm looking for. So nuclear means will cause elements to be broken down, but we're talking chemistry, and we cannot break them down chemically. What can we break down chemically? Not physically, but chemically. Compounds. Compounds can be chemically separated. Can be chemically separated. All right, so that's all of our pure substance side. Now we're going to switch over to the mixture side. You need to add a couple things to your notes here. Fancy words, you learned these a long time ago probably. Homogeneous and heterogeneous. And I scooted too far. It's heterogeneous. Heterogeneous. Homogeneous and heterogeneous. 2 types of mixtures, homogeneous and heterogeneous. Homogeneous means the same throughout. Heterogeneous means different. So if I gave you a choice and I said to you, I want you to classify Raisin Bran cereal. Heterogeneous. Vanilla ice cream, not fancy vanilla ice cream, soft serve, cheap vanilla ice cream. Homogeneous. Could you also say they're mixtures, both of them? Could you also say it's matter? You follow? So there's lots of ways to classify it. Okay. All right. They can be physically separated. Now you're saying, wait a minute. Okay, I'm going to go get a Frosty. By the way, they're 50 cents at Wendy's. A really good deal. 50-cent Frosties. Okay, so I'm going to go get a chocolate Frosty. And yeah, that would be a mixture. That's a homogeneous mixture because it's the same throughout. Now, how am I going to separate that? She said that they can be physically separated. That's a tough one. Anybody know a method of separation that would work for that? Let it melt, or you don't have to let it melt, just heat it up. Boil it, and then what's going to come off of it? The water, what's going to be left behind? The milk or whatever else made up, the chocolate, whatever else, the sugar, whatever else was in there. Well, then you say, well, that's not completely separated. And I agree. Then you would have to find something that would dissolve one of those things but not the other, and do the same process again of distilling, which is the method you basically described there. And you'd have to keep doing that. So it'd be kind of complicated. Now let's go easy. That was a hard one. Salt water. How would you separate salt water? You've already answered it. boil it, and what's going to be going off, or you could distill it and catch the distillate, which would be the pure water. What's going to be left behind? Salt. Okay, sodium chloride. So what are some ways, when I say they can be physically separated, what are some ways to physically separate? Physical means of separation: distillation. Distillation, and that includes evaporation and condensation. That's what that includes. What if I just had muddy water? How can we separate muddy water? Settle, filter, filtration, okay? Filtration, settle out. Something goofy, I told you I could classify myself as a farmer. We have goats. And when we're kidding, that means when we're having baby goats, we have our water in 5-gallon buckets. Well, somebody's job every day when the babies are being born, because the mamas are in their little 5-foot by 5-foot pens, and every day somebody takes like a little, it's a strainer. It's actually not from our kitchen. I purposely bought it for this. But it's a little strainer. It's a little metal strainer with a handle on it, and you stick it in the bucket of water and you scoop out the poop. Because goat poop is pretty cool. It floats, so you can just scoop out the poop, and that's what you do. And so is that a method of separation? Yeah, that's a method of separation. That's called a sieve. That would be a sieve, okay? So all of those. What about magnets? Are magnets ways to separate mixtures? Recycling plants, guess what they can do? They can use magnets, strong magnets, to pull out the iron and separate from the aluminum. They can do that at recycling plants. So magnets, magnetism. So again, one of the things about this class, some of you are not going to be, well, let me rephrase that. Most of you are not going to be chemistry majors, and I understand that. Chemistry is my job, but it's not necessarily all my life by any means. You guys, or most of you, are going to be nursing majors. But guess what? You live in this world, and you are going to be using matter, and you are matter, so you need to understand it a little bit. So you came into this class, and you were absolutely scared to death, and you're dreading it, and you hate it. Chill. It'll be all right. I promise you, okay? Now, today, we're going to actually keep going with measurement. But this is all we're going to talk about with matter. This is some of the old stuff you learned, most of you, a long time ago in a basic chemistry class or a physical science class. So we're going to move from that into measurement. This is where we are going to spend most of our time. And I do see something in the notes I want to correct. It says chapter 2 here. This is actually chapter 1 in your book. The chapter numbers are actually from my other book, but this is chapter 1 in your current free book that we're using. Probably one of the most misunderstood concepts in chemistry, and honestly I think it's probably one of the things that's taught the worst, to be honest with you, is significant figures. If you can understand significant figures in the real world, it makes it so much easier, and that's what I'm going to try to explain to you. First of all, though, we're going to define it. Something I want to tell you you're never going to see on my test. You are absolutely never going to see definitions on my test, ever. You will never see a definition. You will never have a verbatim question where it says, what are significant figures, and then there's a blank and you fill it out. That, to me, is just really low-level learning. Instead, what you're going to be doing is using significant figures from this point forward all the way to the end of the semester. So we're going to talk about measurement. Now, this is probably one of the most misunderstood concepts that's ever taught in chemistry and learned, to be honest with you, in chemistry. But to me, it's one of the most important things because it's something you actually will use in real life. So first, let's look at significant figures and what they are by definition. By definition, significant figures are those digits in a measured number that are known with certainty plus the first uncertain digit. Those digits in a measured number that are known with certainty plus the first uncertain digit. Couple things I want to point out here and kind of dissect this statement a minute. Measured number. That's the key. The key to understanding significant digits is the fact that it is a measured number. Guys, if I said to you that there are 45 students in this class today, 45, did I measure you? No. What did I do? 1, 2, 3, 4. I counted. So can I say that significant figures apply to the number 45 students? No, they don't apply. Now, if I said to you that I have, or let me say this way, I used to have a height of 68 inches, then in that case, did somebody measure me? Yes, somebody measured me with an instrument. So then when I'm looking at the number 68 inches, can I apply significant figures to that number? Yes, it has significant figures. So now let's dissect 68 inches based on this definition. First of all, 68 inches is measured. And it says the significant digits are those digits in a measured number that are known with certainty plus the first uncertain digit. All right, that uncertain digit is the guessed at digit, which means let's say that someone measured me with a ruler or a measuring tape that was marked off every inch. Every inch there was a mark, okay? That means with certainty I'm 68 for sure, right? Because you had a mark at 68. Now if I was exactly 68, then that means that I'm at the line of 68. Which means then, how do I tell the reader that the instrument's measured in inches every 1 inch? What do I have to put if I'm using proper significant figures? 0.0. Because significant digits are those digits in a measured number that are known with certainty, then what's it say? Plus the first uncertain digit. So if your instrument allows you to guess, then that's the uncertain digit. But if it's on the line, then what is that? 0. So we're going to look at some examples of this, but before we do that, I'm just going to simply show you a ruler. So I have a ruler here, and here's our ruler, and I'm going to tell you right now, only good carpenters can measure in inches using proper significant digits. Seriously, people that are good carpenters can use this. I'm going to talk about this one, but we're going to mainly focus on the metric system. So let's look at the metric system. So this instrument is marked off, meaning it's calibrated every millimeter, or we could also say, because this ruler says centimeters, I'm going to say that this is 1/10 of a centimeter, and that is correct. So in other words, we say this instrument is calibrated in tenths. If I wanted to measure, let's say that I had a line that stopped right there. So I'm measuring all the way from this point here at the 0 point to right there. And I just picked that randomly because it's a good sticking up area. And I'm going to read that measurement, and I'm going to read it at the far side, the absolute farthest that it goes. How would I do that? Well, what do I know with certainty is the length to this point? With certainty, what do I know? I know for sure what? 5 centimeters. And then, is there a line 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9? Yeah, so with certainty, I know 5.9 centimeters. With certainty. But is it exactly 5.9? No, it's not. Now remember, I'm going to the far side of it. So what do I have to do to be proper significant figures? Guess. I have to guess. So what do I say? 5.9. Well, it's not on the line. Remember, I'm going to this side of it. So what would I say? 5.9. It's hard to see. From what I can see, it's past even 0.5, or it's past the halfway mark between these two, from what I see. I would call it, and what's confusing you maybe is the fact that this says 6. This is the 6th line. It's not to 6 yet. So I would probably call it 5.98. That's probably what I would call it. Again, I'm not seeing exactly how you're seeing it. We're going to the far side. What's the point, though? That 8, or that 6, if you called it a 6, is what? What's it say? Uncertain. It's uncertain. So that means it's the guess. It's the guess. But is it a significant figure? Yes, because what it does is it tells the reader of that number, hey, that instrument that she used is calibrated in tenths, and she guessed at hundredths. You have to learn how to measure properly. On your first exam, you are going to have questions that ask you to measure things, and you need to know what you're doing. It's honestly one of the most missed questions. People don't know how to measure. It's important in real life. Guys, get in your head, significant figures, it's not confusing. It's an instrument. It's how to use an instrument. So let's go through some examples real quick. If you have an instrument that's calibrated in tenths, what are you going to guess at? Hundredths. If it's calibrated in ones, like 1, 2, 3, 4, 5, 6, 7, 8, what are you going to guess at? Tenths. You follow? And those all have to be written down. That's significant digits. Now, some numbers do not have significant digits. So what are some numbers that don't have significant digits? Well, some numbers that do not have significant digits are counted numbers or defined quantities. And in those cases, we just don't even use significant digits at all. So get some examples of those. Let me give you some examples. Exact numbers are things that are defined quantities that have been defined. And some examples, 12 inches equals 1 foot. And you say, who came up with that? It doesn't matter who came up with that. The point is, somebody sometime said 12 inches are going to equal exactly 1 foot. 5,280 feet are going to equal exactly 1 mile. 100 centimeters equals a meter. Those are defined quantities that we say we don't worry about significant figures for. So we don't worry about it. Counted numbers, so the number of people. Money, no significant figures. We don't use significant figures when we're dealing with these. So if I say to you, you owe me $25.32, do I say that's for significant digits? No, I say don't worry about significant digits because it's counted. You don't worry about significant digits for counted numbers. So when do we? What do significant figures help us understand? An instrument. The purpose of significant figures is all about the instrument. So one of the things that you were supposed to print out today, and this is in the day 1 notes, is the measuring temperature with various degrees of precision handout. And this is what it looks like. You actually have 3 thermometers on this page. So we're going to simply read these. You're going to tell me what the measurements are. If you are working for me in lab, and this is in degrees Celsius, by the way, if you were working for me in lab, I would say to you, okay, give me the temperature of thermometer A. And if you are a good reader of instruments, you're going to give it to me using correct significant figures. So let's figure it out. Significant figures are those digits that are known with certainty plus the first uncertain digit. What do we know with certainty is the temperature of thermometer A? 21 degrees Celsius. With certainty, we know 21 degrees Celsius. That means this is my certainty, and then what do we have to do? Make a guess. We have to pick the uncertain. How do you do that? Well, you kind of judge halfway, and then you say, okay, I'm going to take a guess. And call it what? 0.2. That's what I would call it. 21.2 degrees Celsius. And then we can say, these are my certain, and this is my uncertain. So significant digits are all digits in a measured number. What's my measuring device? A thermometer here. How is it calibrated? Calibrated means how are the tick marks? What are the marks? It's calibrated every 1, 2, 3, 4, 5 degrees Celsius. So if it's calibrated in ones, what do I guess at? Tenths. Now, are all three of these significant? Yes. So total, this has 3 significant figures. It has 3 significant figures total. All right, the next thermometer, thermometer B. What do you know with certainty is the temperature of thermometer B? 22 degrees Celsius. With certainty, we know it's 22. Meaning what? It's on the line. It's on the line. So why do you have to put 0.0? What does that, putting that 0.0, what does that do? It tells whoever's reading that number, in other words, now we could say, I have a random number. It was obviously measured because it says degrees Celsius. What does that instrument look like that measured that number? It was marked off every what? 1 degree Celsius, but it was on the 22 line. You can tell all of that just from looking at that number if you understand significant digits. Significant digits are about the instrument. That's what you've got to get in your head. That is one of the things that people don't get. I didn't get it when I first started teaching. I didn't get that. But significant digits are all about the instrument. Now I can take any number and I can tell you what the instrument looked like that actually read that. All right, so let's go now and let's look at the last example. The last example is a more what instrument? Somebody used this word earlier. More precise. This is a more precise instrument, meaning it has tick marks in a closer arrangement. How is this instrument calibrated? See, it's actually calibrated not in hundreds, it's actually calibrated in tenths, and that means you're going to guess at the hundredths. So it's hard to read. What do we know with certainty is the temperature? We know with certainty it's 22.1. We do know that it is above this, and it's hard to see. That is very, very hard to see. You can pretty much tell it by where the location of the other ones are. But it is definitely either on the line or above it. I'm going to say it's above it, reading it like I can see it. I'm going to say it's above it. Which means then 22.1, and then what do we have to do? Guess. And the crazy thing is it's actually harder to guess at because it's more precise. But in the end, does it make your answer better? Yes, because what do you know with certainty? We know with certainty 22.1. The guess is a better guess simply because you knew the one. What do you want to call it? 22.1? What do you think up front? 3, 2, that's what I would say. It's hard to see. And again, most of you can see your paper better than you can see this one up front. But again, what are we all doing? We're guessing. Meaning, what is this digit in our rules for significant digits? It's the what? Uncertain. So this is uncertain. These are certain. But total significant digits, how many do I have in this number? Are they all significant? Yes. So I have 4 significant figures. Now, in this example, I didn't actually say how many significant digits. How many total significant digits are here? 3. Good. That 0 is significant. It is significant because it tells us about the instrument. So that's a total of 3 significant figures. Try some of these. There's another video on Blackboard with the videos and worksheets that you can actually print off, and it will have some other examples. Guys, even if you don't watch that video, let me just show you what that looks like. This is the sheet. Even if you don't watch the video, just practice. Practice reading those instruments and figuring out significant figures. Practice just doing the worksheet. The answer key is on Blackboard as well if you don't want to watch the video. And so any extra practice, just measure something in your house and make sure you're using your ruler correctly. Any of that will help you. Before we leave this, I need to refresh your memory on some things because I can guarantee you some of you have forgotten this. Place value. So let's see. Let's go back kind of right here in this space. Just kind of refresh our memory here. What is this place called? Ones, tens, hundreds, and if we went on it'd be thousands, 10,000s, etc. What's this called? Tenths, hundredths, thousandths, and then 10,000ths, etc. We typically don't go that much farther down. I'm going to ask you questions, and this is one of them. How were the instruments calibrated that measured these numbers? These are the words I want. Okay? Now let's recall. Significant digits are those digits known with certainty plus the first uncertain digit. Okay, so those digits known with certainty plus the first uncertain digit. That means the last digit that's written down is the which one? Uncertain. So is that how the instrument's calibrated? No. Which one is how the instrument's calibrated? The one before the last one. You with me? So this is the last certain digit. That's the last certain digit, which means how is this instrument calibrated? Hundredths. This one's calibrated in hundredths. This is the tenths. This is the hundredths. This is the thousandths. So it's calibrated in the hundredths, and you guessed at the thousandths. Thank you. All right. That's why you're in this class. All right. How is this instrument calibrated? What's the last uncertain digit? I'm sorry, what is the last certain digit, I should have said. What's the last certain digit? So how's it calibrated? Tenths. Good. Now you're going to get this one. You're going to get this one, okay? How is this instrument calibrated, Andrew? How is this instrument calibrated? Ones. Very good. This instrument is calibrated in ones, and you guessed at what? Tenths. Good job. Now this is a really odd number. You seldom see a number with a 0 at the end and a decimal after that. Why do we see it here? Because it is telling you the 0 is significant, which means the 0 is the last significant digit, which means it is the uncertain digit, which means how's this instrument calibrated? Tens. Now how did that look? Now this is goofy, but just imagine, if you will, I mean the unit's miles, so it's really crazy, but imagine if I had a string and I started here and I kept walking for 300 miles and I'm unrolling my string, but there was a mark on it every 10 miles. Do you follow me? There was a guy around Bowling Green recently that was pulling a ball, a big ball. So there, you know, things like this could happen. And so that's what that instrument would look like. So that would be what that would look like, where you would go every 10 miles and it had a mark. That's what that instrument would look like. Now this one does not have the decimal. That means that this 0 is not significant, which means that this is uncertain, which means how was this instrument calibrated? Hundreds. Now unfortunately today I didn't bring my fancy jar, but I actually have a jar, not in gallons, But I have a jar, a quart jar that looks similar to this one, but instead of having no marks, it actually has 100 milliliters, 200 milliliters, 300 milliliters, 400 milliliters, 500 milliliters. Guess what? That jar is calibrated in hundreds. So if I were going to read my jar that was calibrated in hundreds and it were 250 milliliters, let's say, would I put a decimal at the end of it? No, because what do I know with certainty if that were the case? Hundreds. And then I'm guessing at the tens. That's what this instrument looks like. Remember, significant digits are all about an instrument. And this statement is so important. The last number is the uncertain digit. So every one of these, that's the uncertain digit. The number before the last number is the last mark. That's the calibration mark. That's how the instrument's calibrated. Now, I told you earlier that only good carpenters can do this. Let's see if I have any good carpenters in here. So I'm looking at this thermometer, or not a thermometer, ruler rather. Looking at this ruler. Now, you got to be good with your fractions. Can anybody tell me how the ruler in the inches is calibrated? Sixteenths. That's exactly right. This ruler is calibrated every 16th of an inch. So in other words, you've got a 16th, 2/16, which is the same as what? 1/8, 3/16, 4/16, which is 1/4, 5/16, 6/16, 7/16, 8/16, which is half an inch. Now, if you're following the rules for significant figures using this ruler, guess what you would have to measure in? How would you have to give your answer? Say it. 30 seconds. That's exactly right. In other words, if you were, let's say that you were right here. If you were measuring something that was right there. 1/16, 2/16, this is 3/16. I'm not sure where I said right there it was. Let me do this. So if 1/16, 2/16, 3/16, it's more than 3/16, but it's less than 4/16. So then you have to go back and you have to say this is actually, there you go, because this is 8/30 seconds, and this would be 6/30 seconds, so that'd be 7. That's exactly how you have to measure it. If you were using proper significant figures with inches, that's why metric system, even though we may fight it, it's a lot easier in the metric system. Much easier, much easier. Okay, before we quit, we're going to look at what is significant. When is 0 significant and when is 0 not significant? So let's look at the rules for 0, and then we'll review this next day as well. But let's look at the rules for 0. I've already mentioned, honestly, the answers to some of these, but let's give the rules for a minute. First of all, you've got to get in your head only who can have significant digits. What kind of numbers have significant digits? Say it. Measured numbers. Only measured numbers have significant digits, period. Nothing else has significant digits except measured numbers. So in a measured number, 1, 2, 3, 4, 5, 6, 7, 8, 9, they're significant. So anytime you have 1, 2, 3, 4, 5, 6, 7, 8, or 9, and it's a measured number, it's significant. So let me just throw out 323 meters. That has 3 significant figures. Anybody have a problem with that? Makes sense. 3 significant figures, 3, 2, 3, 3 significant digits. That one's pretty simple. This one is as well. Zeros between non-zero digits. So 303 meters. Is that 0 significant? Yes, it's between non-zero. It's significant. So that's also 3 significant figures. Not a problem. Next one is a little trickier. It says zeros in front of non-zero digits are not significant. These zeros are used to locate the decimal. We'll give you an example. We'll give you 2 examples, actually. We're talking about this 0 right here. So it says zeros in front of non-zero digits are not significant. Now, I think all of us will agree that is not significant. In fact, most of you would say it's not important. In fact, many of you would leave it off. Let me warn you, don't. Don't leave that off. Why don't I want you leaving? Because I know what you're going to say. Do I have to put the 0? Do you have to wipe your bottom? No, but would it be nice? Sure. You know, I mean, it's nice to put this here, okay? Why is it nice to put this here? Because I don't know if you meant a stray mark or a decimal. So put it. Put the 0 in front. But is it significant? No. How many significant digits are there? 3. So that has 3 significant figures. So that one, I think most of us get that. Again, our problem with this scenario is that we use 2 words interchangeably in our world. If I say I have a significant person in my life, I would say that person is important, right? All right, let me show you this. We've already established this 0, which is this 0, is not significant. It's not even really important. Great to have it, but not important. Now this one, is this important? That is an important 0, but is it a significant digit? Read the rule. Zeros in front of non-zero digits are not significant. That means what? It's not significant. But you say, but I need it. It's important. I agree, it's important. But is it, by definition, a significant digit? No. What's it being used to do? Locate the decimal point. So this only has 3 significant figures. Now, can anybody tell me what better way this might be written? There you go. Might best be written in, what's that process called? Scientific notation. And for those smart folks, you got it, 8.59 times 10 to the negative second. So this shows for sure how many significant digits? 3. This was a little confusing. Now there's something else that I left out on both of these examples that nobody caught me on. Does anybody know what I left out that I should have written down? All significant digits are measured numbers. I didn't put any units there, did I? Let's go back and do that so that you don't look later and wonder, why doesn't she have units? They had to have units. Some of you are saying, I have no idea how to do scientific notation. Don't fret. I'm going to teach that next class period. But for right now, understand these are not significant. These 3 are. If you want to show for sure 3 significant digits, write it in scientific notation. Let's look at the next 2 examples. Zeros at the end of a number that includes a decimal point are significant. We've seen this example earlier. 450 with a decimal meters. How many significant digits are there? Go ahead. 3 significant figures are here. 3 significant figures are there. Is this a significant digit? Yes. How is this instrument calibrated? Tens, and you guessed that? Ones. That is the uncertain digit. Okay? Let me show you another example of that you may see more often. Is something like that. 35.00 milliliters. How many significant digits would that have? 4. All of those are significant. How is this instrument calibrated? Tenths, and you guess at the hundredths. Good, good, you're getting it. All right. Last example, zeros at the end of a number without a decimal point are not significant. So 855,000. 855,000 grams. This does not have a decimal. Now, it's an understood decimal. It's a whole number, obviously, but it does not have a decimal, which means these are what? Insignificant, which means how many significant digits are in this entire number? 3 significant figures. Let me show you another example. 870 liters. Again, it does not have that decimal at the end. How many significant digits does that have? 2 significant digits. Now, in this case, most of you see this. This one may be a little harder. In either situation, might it be also best to write those in scientific notation to show significant digits? Anybody want to take a guess on this one? How would that be written in scientific notation? 8.55 times 10 to the what? 5th grams. Good job. And this would be what? Times 10 to the 2nd liters. Good job. Do you put the 0? This is where people often mess up on this one. Now, the big one, they won't. They won't put those zeros, but here they want to put the 0. Don't put the 0. Why not? Because it is not significant. And again, so you say, I don't remember anything about scientific notation. Well, flip the page over and guess what? The next topic is scientific notation. So let's plan on starting on that next class period. Before you leave, though, I want to just remind you a couple things you have to do before you come back next class period. Your sapling homework, every sapling homework group, every homework assignment, there are 5 assignments. Every sapling homework assignment has at least 46 questions. They're worth 23 points. The first one, I believe, has 46 questions. Later on, there's actually going to be a homework assignment that has, I think, close to 60. If you wait until the day before they're due, it's not going to be helpful. I have limited the amount of busy work in this class compared to what I used to do. I used to use Learn Smart and Connect, which is a McGraw-Hill product, and you had an assignment due every class period. I'm not making you do that. Instead, what I am having you do is, and expecting you to do, every day after class, do a few of the sapling homework problems. That way, when it comes time to turn it in, it's done. And it's all finished, and you don't have to worry about it. So please, go on to sapling. I try to put these in the order of lecture, so you can get the first probably 8 to 10 problems done right now. Again, also, you're saying, I still don't understand this. You get the video again. Watch it again. If you still don't understand it, you have more videos on Blackboard. You have more worksheets. And, of course, you have tutoring that you can go to after the first week of classes. That'll be started. And you can always ask me. My office hours are on the back. So have a good day, and I'll see you next day. Oh, before I forget, I told you earlier I was a farmer, right? That was one of my classifications. My birthday was last Monday. Had a birthday. Just remember that. August 7th is my birthday, if you want to remember that for future. And guess what I got for my birthday? Well, there's a picture of it showing up. I got a bush hog. Yep, I got a bush hog for my birthday. Hallelujah, baby. I love my bush hog. I've named her Ellie because of the fact that she's yellow, and you're seeing her there in the picture with Johnny Tractor. And I will tell you, Johnny has taught me a lot. He's an 80s model. Ellie is a 2017 model, so they're a perfect, little fit together. But no, I bush hogged 2 fields, and I'm quite proud of myself. So, one thing I will mention, you'll hear me talk a lot about farming in this class, and we're you and I are in the same boat, many of you. Some of you are freshmen in this class, and interestingly enough, I could retire in 4 years. Now, will I retire in 4 years? I don't know yet, but I could. And just this year, I've really upped the ante at what I'm trying to do on my farm, and I'm learning a lot. I have never bush hogged until this past week, so I've learned a lot about bush hogs, and that was kind of like overwhelming. I know that sounds corny for some of you, but for me, I was taking notes with my mechanic guy who brought me the bush hog, and I'm taking notes on how to use this bush hog, because it's not as easy as you think. I mean, this is a massive 15-foot whopper bush hog here. And so I'm taking notes, and I'm learning, and I'm feeling overwhelmed. Some of you guys right now are totally feeling overwhelmed in this class. You can do it, okay? I'm in a learning mode of farming. You guys are in a learning mode of chemistry and nursing or whatever else you're in. So we both have 4 years to go. We'll see what happens at the end of it. But have a good day.